understand the concept of how do we apply this integration, let's start with an example. See, in this problem, you're going to understand how to solve a problem. Along with that, the concept what is involved in this application of integrals chapter. Fair enough? Now, look at this particular question. You have x-axis and y-axis. Alright, so this is the x-axis, y-axis, the coordinate axis, and the circle with center O at the origin. Okay, say that the radius is going to be A. Fair enough? See, if you have A as the radius, then the equation of the circle is going to become x square plus y square is equal to A square, isn't it? This much you all know because this is you have already learnt it last year, the equation of a circle at the center. Now, how do we find the area of the curve? This is the question. Now, to understand that, how do we find the area of a curve? See, for a circle, if you look into this one, you start from a point on the x-axis. In the sense, we start from this point, isn't it? And then we move all the way, we come to the same point. Now, in the previous chapter, you have learned that integration from a to a f of x dx, this is going to become 0, correct? Because you get f of a minus f of a, which you know the answer is 0. That means we cannot use the previous method integration. So what we do is, we find the area of one quadrant multiplied by 4. Because you know that a quadrant into 4 gives you the area of circle. Correct? Now in this case, what we do is, see the first quadrant, the quarter of a circle. In the first quadrant, first thing what we'll do, we'll divide this into a small strip. In the sense, we are going to divide this into a small strip. See, if you find the area of this small strip of area, you can call it small strip area. Some area you will get, correct? That's very simple. The next what you do, take the same strip, take it to the next case here, and then again you divide it here. Again you find the area of this strip. Okay, again you find the area. Then keep doing it. Keep doing it. So take it here, again you draw one here like this, and then again you are going to divide this. Now what I want you to understand is that each area of the strip is going to be very small, correct? And you keep adding, adding. Once you integrate or once you add everything, then what's going to happen? That's going to give you the area of that particular quadrant. So this is the meaning of integration. Integrate, meaning to sum up, to add things. Now, what are you adding? These small rectangular strips, what you're looking at. Of course, it doesn't look like a rectangle in my figure. But think about it. Every time you draw a small, figure, like two lines which are parallel to each other. Now, if you start reducing the width of that particular rectangle or those two parallel lines, at the end, the distance will be so close that it almost feels like it's a rectangle, correct? It almost feels like it's a rectangle. So in this particular figure also we are doing the same thing. We are taking this particular strip, whatever we have, we are trying to make it as zero as like as close and as small as possible. Okay, the reason why we are doing it, because the smaller and smaller and smaller it becomes, the more accurate we can say that it's becoming a rectangle. The more accurately we can say that it's a rectangle. If the width difference or the width size is going to become bigger and bigger and bigger, then there are a lot of errors which can occur in this particular, not in this one, any other figure for that matter, isn't it? So to reduce that error, what we do, we take a very, very, very small strip. So in this particular figure, what are we taking? So we are taking a small strip in the x-axis. In the x-axis, again I'm telling you, this one. See here, the small strip along the x-axis, and we draw two lines parallel, which touches the curve. Okay, which touches the curve. So that, with the help of that one, we can calculate the area of this entire figure. Now the next question is how, correct? So we'll look into that now. Find the area. Let's start with the equation given. See, equation given is what? X square plus y square is equal to a square. Now there are two methods of solving. This is where you guys need to be very, very, very attentive, because the method of solving, one, and the types of solving, two. So two things you are going to learn once. That's why pay attention. Now there are two ways. One of the ways is where we take in terms of the strips what we have done. What you can see here, right? We get is small strips along the x-axis, correct? That means every distance what you see here, let's call it as dx. And every vertical distance is y, correct? Vertical is y, small length is dx. Now, what will be the area of this particular rectangle? It's going to become y dx, length into breadth, right? So, in this case, it's going to become integral of y dx, because y dx gives us the area of one strip, and we are integrating every strip. Keep adding. Once you keep on adding everything, you are going to get the area of the entire quadrant. But when you say entire quadrant, don't you think quadrant has a particular limit? In the sense, it starts from here, ends at here. We have starting and an ending point, isn't it? Now, any circle or any quadrant starts from the origin, then you increase the radius, decrease the radius. Based on that, the size is going to change. So here, integration of y dx from 0, that means we are starting from the origin. They finally go to the point A, which is point A is what? That is the point on the circumference of the circle. Complete 0 to it. Okay, now integration of y dx from 0 to A. Now this basically gives us the area of the quadrant. Only the quadrant, guys, not the entire circle. So for circle, what do? You multiply it by 4, right? We'll do that at the end. The last part will multiply by 4. So in this case, capital A is equal to root of y dx from 0 to A. Now what is y? Root of. Because see this here, x square plus y square is a square. So y becomes root of a square minus x square. This is the value of y. Substitute that value of y. That means root of a square minus x square into dx. Clear? What I want you to understand, which is extremely important. Again, I'm telling you, this is a very, very, very important point. Now, if you are splitting the graph along the x-axis in terms of pieces of y, then the area is going to become integral of y dx from a to b. From a to, guys, it's not always 0 to a, because 0 to a is only in circle. Ellipse changes, parabola changes, some random very weird curve, it changes, everything is different. But the formula is the same. That's the integration of y dx, because dx is the small horizontal distance, y is the big vertical distance. Horizontal into vertical is going to give you the area of the rectangle or area of the figure. You add all the figures, you integrate all the figures. That's going to give you the area of this particular curve. So now let's do this one. You have root of a square minus x square dx 0 to a. Correct? Since we are talking from 0 to a, and we are talking from root of a square minus x square. Now, if you guys remember, you had done a problem based on this integration of root of a square minus x square. Okay, now here there are no constants to keep it out, just the root, correct? So this is going to become x by 2 into root of a square minus x square plus a square by 2 sine inverse x by a. Now, you have to apply the limit, right? And for this question, what is the limit? 0 to a. Now we apply value. Very simple. X by 2, which is a by 2 into root of a square minus a square. Correct? Plus a square by 2 sine inverse of a. Sorry, sine inverse of a by a. Now, a square minus a square is 0. 0 into this one is gone. Correct? So, what are you going to have? Just a square by 2, because sine inverse of 1 by 1. What is, sorry, sine inverse of a by a, sine inverse of 1. Sine inverse of 1 is pi by 2. So, we got a square by 2 into pi by 2. Remember, I've just applied the upper limit. I've not even done the lower limit yet. Now, we'll do the lower limit. Okay? The value is going to become 0. X by 2, 0 by 2 into anything is 0. Sine inverse of 0 is also 0. So what do we get? A is equal to pi a square by 4. But this is the area of one quadrant, right? So final area will be what? So total area of circle. This is 4 times the value. That means what do we get? 4 into pi a square by 4. 4 and 4 cancels. Therefore, what do we have? The area of circle. Area of circle is equal to 4 into pi by 4 a square. 4 and 4 cancels. Pi a square. If you remember, pi r square is the area of a circle. Now, see, what is the important point? What is more like a takeaway from this particular problem? The takeaway is that you did y dx. That means you split the curve into n number of thin slices with the x-axis, you can say the breadth or the x-axis distance, it's up to you. That is dx and the length is y. So you took y dx and you solved the entire problem. Now in the next video, we'll try to do the same, not same problem, but similar type of problem by using another one, which is x dy. We'll discuss that in the next video.